All right, so we're going to prove the law of cosines. I have not stated the law of cosines and I have not finished the picture, but I wanted to start at this stage of the picture because I just want to recall that we derived the law of sines from that area formula, that the area of a triangle is 1/2 times one side times another side times the sine of the angle between those two sides. And I keep saying how important this little theorem is. So you can derive the law of sines from it. And to prove this theorem, basically, we had the same picture. We used 1/2 a times h and h. We used 1/2 a times h and h turned out to be b times sine gamma. It was just that simple. It's the same picture for the law of cosines. In fact, if we look at triangle, if you look at the right triangle EDC, in that right triangle, we see that sine gamma is h over b. So when we solve for h, we get b times sine gamma. By h, I meant the height or altitude, this line segment, but I didn't even want to introduce h, just b times sine gamma. And then cosine gamma would give us this side, right? To set up a trigonometric statement involving line segment DC, we're going to use cosine. Cosine of gamma is DC over b, and therefore DC is b times cosine gamma. After a while, this should not be no surprise that you have a right triangle. Given the hypotenuse, the other two sides are the hypotenuse times sine gamma, hypotenuse times cosine gamma, where gamma is not the right angle. And now we just have one more thing to do. We are going to discover that this remaining thing here, BD, is no more, no less than A minus B cosine gamma, right? The whole thing is A, and then we take away B times cosine gamma. And now we're going to state the Pythagorean theorem on this triangle. So the Pythagorean theorem for this triangle goes like this. A minus B times cosine gamma squared plus B times sine gamma squared equals to C squared. A minus B cosine gamma squared plus B times sine gamma squared equals to C squared. Just the Pythagorean theorem on this little right triangle. And now we're just going to work the algebra. We get A squared plus B squared times cosine squared gamma minus 2A times B cosine gamma plus B squared times sine squared gamma. And look at the stuff that has B squared in it. We have A squared plus, we can factor out B squared, and then inside the parentheses, we're going to be left with cosine squared gamma plus sine squared gamma, which in the next line, we're going to recognize it to be 1. Minus, we just carry the 2AB cosine gamma. And so here is the law of cosines. C squared equals to A squared plus B squared. It's B squared times 1 is just B squared minus 2AB cosine gamma. So this is what we call the law of cosines, and it's one of the most important trigonometric identities. It's very useful in finding sides and angles in triangles. We're going to see it again and again. Thank you for watching.